Alright, let's look at number 28. An equilateral triangle of size measuring 6 centimeters has its base on the x-axis. So let's do the base first. There's the base, it's on the x-axis and it measures 6, therefore it will end at 6. And one end of the base is at the origin, whether it is at the origin, and the other end ends on the positive x-axis. So it's equilateral triangle. So we'll have a triangle, the sides coming down there, sorry about that, and sides coming down there, and all the sides measure 6, 6, and that measures 6. It's equilateral. Now, they want us to find the equation of each side. So what we'll do, we'll just, you see this line is called a northeast line. This is a northwest line. That's why we wanted you to learn those things. And just for interest, we'll call this line 1, line 2, line 3. Right. You want to find the equations of line 1, line 2, line 3. Now, let's write L1 here. Now this is an equilateral triangle. You are given that point, you don't know what is that point, you know what this point is. So it's easiest to find the equation of this line first. So you will learn that whatever you know and you can find first, write that down first. So this is line 1. Clearly it is a line passing through the origin. Therefore its equation is y is equal to 0. If it was there, y is equal to 4, y is equal to 3, y is equal to 2, y is equal to 1. Therefore if it's here, it's y is equal to 0. So we finished that. So we only got that line and that line left. Now when you study this diagram, you need information. So it's a little bit of a problem, a challenge. So what we do, we think about the properties of an equilateral triangle and we decide, let's draw the height. I don't know what you did, but suppose I said draw the height. Now the height of an equilateral triangle bisects the base. It bisects the base. Therefore, from here to here, it is 3. And from there to there, it is 3. It bisects the base. So this is 3 and that is 3. Now, if you take the shaded triangle, and if I just draw it separately here, then from here to here it is 3. From there to there it is 6 because it's an equilateral triangle. Now what we don't know is how long this is. But by theorem of Pythagoras we can find this. Let's just call it h. So we're trying to find h. By theorem of Pythagoras, h squared is equal to, or let's do it the long way, other side squared plus other side squared is equal to the hypotenuse squared. This is the hypotenuse. So, and this side is 3 squared. That side is h squared is equal to 6 squared. H squared is equal to 6 squared minus 3 squared. H squared is equal to 36 minus 9, you'll end up with 27. So h is equal to square root of 27. So this is square root of 27. So what it means that this line here, I'll just take out this just to, is square root of 27. So the distance from there to here is square root of 27 and the distance from here to here is 3. Therefore we know what that point is. That point is x is 3 and y is square root of 27. So that point is now 3 square root of 27. That's your x, that's your y. So now we know what that point is using a little bit of theorem of Pythagoras. Now, to find the gradient of this line, let's say the northeast line or line 2, it's actually passing through 0, 0 here, 0, 0, and it's passing through 3 root 20, 3 root 27. So you can find the gradient of this line here. So the gradient of this line here, I'm dealing with line 2, is y2 minus y1 over x2 minus x1. So let's call this x1, y1, x2, y2. So y2 is the root, oh no, let's take the root 27 and let's find its value. Root 27 is equal to, let's find its, in the calculator, you'll find that root 27 is equal to 5, 2. 5, 2. So instead of saying root 27, it's better for me to say 5, 2. It's better for me to say 5, 2. And root 27 is equal to 5, 2. So that point is 3, 5, 2. Right? Root 27 is 5, 2. So it makes it better. So this one, instead of saying root 27, I will say 5, 2, correct to one decimal place. So it's 5, 2 minus 0. 5, 2 minus 0 over 3 minus 0. And when you, that's 5, 2 over 3. And when you put that in the calculator, 5, 2 divided by 3, you should end up with 1, 7, correct to one decimal place. So the gradient of this line is 1, 7. So you can see it's a northeast line, and you can see the gradient is positive. All northeast lines have gradients which are positive. Now this was one way to find the gradient. The other way to find the gradient is this. You can find gradient by saying it is change in y over change in x. Now the change in y is square root of 27, which is actually 5, 2. And the change in x is actually 3, which brings you back to 1, 7. That was another way of finding the gradient. Alright, we've got the gradient, and now it passes through the origin. If it passes through the origin, then this is the y-intercept. Now that is the y-intercept. Because it's passing through the origin, this is 0. So that's the y-intercept. And therefore, the equation will be, let's try and finish it here. Y is equal to mx plus c. Y is equal to 1, 7x plus 0. Well, I can leave it like that. Y is equal to 1, 7x plus 0. Or I can say y is equal to 1, 7x. So that finishes line 1, that finishes line 2. Now we have to do line 3. Alright, so let me just move across for line 3. Now line 3, there's line 3 here. It passes through this point here. So if you take this point, it is 6, 0. This point. And that point is 3, 5, 2. So if you can call this x1, y1, you can call this x2, y2. Right? And the m is equal to y2 minus y1 over x2 minus x1. That's 5, 2 minus 6. 5, 2 minus 6 all over 3 x2, sorry, this is wrong. 5, 2 is y2, y1 is 0, over x2 is 3 minus 6. That gives you 5, 2 over negative 3. Put that in your calculator. It's negative 3. And that gives you negative 1, 7. And you feel good too, because you can see it's a northwest line, and northwest lines have a negative gradient. So you got the gradient. Now, this line passes through 6, 0. It passes through here. Passes through 6, 0. So I want to calculate the C, because this is not y-intercept. For y-intercept, this must be 0 and that must be a number. But this is 6, 0. So I'll have to solve for C. I'm trying to find C. So I will start with y is equal to mx plus c, right? And I'm using m is equal to -1, 7. And the ordered pair it goes through is 6, 0. So this is x, this is y. Alright, so we want to follow this carefully. So we are doing line 3 now. Actually, we started line 3 right over here, right? Our working for line 3 starts here. Okay, so we use those 2 points. We found the gradient of line 3. This is the gradient of line 3. Line 3 gradient -1, 7. So the gradient -1, 7, it goes through there. So we substitute y is 0, m is -1, 7, and x is 6 plus c. 0 is equal to, now we multiply that, 1, 7 times 6. I think you'll get -10, 2. I think you will get -10, 2. Let's just check that with the calculator. Six sevens 42, carry 4. 6, 1, 6 plus 4, 10, 10, 2. Right, now we got this plus c. So c is equal to, when this goes across, 10, 2. Now we have m and we have c. So finally y is equal to mx plus c. Y is equal to -1, 7x plus 10, 2. Alright, so with that we come to the end of this exercise on interpreting straight lines. A nice little problem that revises your theorem of Pythagoras, revises your property of equilateral triangles, and combines it with straight line graphs. Alright, so with that we come to the end of this exercise on interpreting straight lines. We do hope that you enjoyed doing this exercise. If you got them all right, great. If you didn't get them all right, you will get it all right next time. So just go through, find out where you made your mistakes, and also let me know if I made a mistake somewhere. So thank you very much, and with that we come to the end of this DVD.